Under the star-filled sky of night, when the rush of life has finally slipped into the distance, perhaps there is still a gentle, familiar turbulence inside you. Thoughts that refuse to sleep, worries that circle slowly, and the quiet questions about the meaning of life that we so often avoid in daylight. But here within the stillness, I invite you to step into a different kind of journey, one where each breath becomes lighter, each thought grows deeper, and every moment feels like it is guiding you back to yourself. Tonight we will travel through the universe at a pace unhurried and soft, not with the speed of a spacecraft, but with the slowing of a mind coming to rest. For as Carl Sagan once said, we are a way for the cosmos to know itself. And perhaps in the exhaustion of modern life, what we need most is not another answer, but a quiet space in which to hear the universe within us begin to speak. Let this voice accompany you. Let tonight become a doorway into peace. Under the quiet descent of night, when the sky opens like a doorway into the infinite, perhaps you have looked up at the stars and wondered what is burning in that distant place. What is it that feeds that light, gentle yet unwavering, fragile yet immortal? And why is it that in the silence of a long night we feel a strange connection to those tiny specks of brightness that left their stars millions of years ago? The answer begins with something that seems impossibly small, the embrace of two light nuclei. At the heart of the stars, where temperature and pressure surpass anything the human mind can imagine, a quiet miracle unfolds: nuclear fusion. Fusion is not merely a physical reaction. It is the heartbeat of the cosmos, the origin of light, the reason humanity's nights have never been completely dark, a reminder that even in the chaos of matter there exist moments of union so beautiful they create the energy that sustains the universe. On the scientific surface, we say that hydrogen, the smallest of all nuclei, fuses into helium, releasing an immense amount of energy. But on a deeper level, this is also a metaphor for us that sometimes from the smallest things, from the most fragile seeds of thought, a power can emerge strong enough to transform an entire life. Carl Sagan once wrote in Cosmos, "We are made of star stuff." And every time we speak of fusion, we are retelling our own story for our bodies. Our minds, our memories were born from the great stellar furnaces that exploded billions of years before we existed. Fusion is stronger than fission, cleaner, and more enduring than any source of energy humanity has ever known. But what makes it sacred is not its strength. It is the purity of the way it creates energy, not through separation, not through breaking, but through union. A becoming one, a birth through connection. Viewed philosophically, fusion is an emblem of creation, the moment when chaos arranges itself into order, when darkness gracefully yields to light. It is the universe's answer to the question humanity has carried since its earliest dawn: where does light come from? Nietzsche once wrote in Suizin, "Thus spoke Zarathustra, one must still have chaos in oneself to be able to give birth to a dancing star." Strangely enough, this describes exactly what happens inside the stars, an extreme swirling chaos of plasma, giving birth to the dancing lights across the night sky. And perhaps within each of us, amid our worries, our turbulence, the unnamed things we carry, there is also a quiet fusion of our own, a small star that has never stopped burning. Fusion is also a story of perseverance. For two light nuclei to overcome their electrostatic repulsion and merge, they require conditions of staggering intensity, temperatures of tens of millions of degrees, immense pressure, and the improbable patience of matter itself. But once those conditions arrive, light appears, not loudly, not theatrically. It simply emerges and radiates outward. There is something in that process that resembles the human journey. We move through pressure, through heat, through the collisions of experience, not to be broken, but so that one day the inner light naturally shines through. Not everyone sees it at once, but it is there like the quiet energy of a star sustaining life from afar. Even through the lens of depth psychology, fusion mirrors the unification of the fragmented self. Carl Jung called this individuation the process by which the scattered parts of the psyche come together to form a mature, coherent whole. The parts that once contradicted each other, the memories we once abandoned, the shadows we once feared to face, all of them one day merge and give birth to our own light. Fusion in this sense does not happen only within the stars, it also happens within us. In the sun, fusion is an endless dialogue between matter and energy, a gentle reminder that life on Earth is sustained by processes that are patient and quiet. Within us, fusion is the reminder that the most beautiful things arise when we allow ourselves to connect to ourselves, to others, and to this vast world that holds us. On the cosmic scale, fusion keeps the sky illuminated, keeps our planet within the habitable zone, keeps oceans from freezing and the air from falling into absolute stillness. On the inner scale, it invites us to soften, to set down the weight of the day, and to return to our original light. And perhaps as you listen to these words in a dim room with your eyes growing heavier, you can feel what philosophers, astronomers, and the earliest sky gazers all felt. That beneath all the noise of life, there is still a quiet order, moving still, a gentle source of light watching over us. And still a whisper small and soft. You too were born from that light. To understand fusion, one needs more than science. One needs listening, stillness, a willingness to let the mind grow light. And tonight, as you drift towards sleep, let this thought accompany you. Among the billions of stars burning in the universe, there is one star burning within you as well. Unhurried, unloud, but enduring and profoundly beautiful. From the gentle radiance where nuclear fusion gives birth to the light of the stars, we continue our journey slowly, as though walking along a glittering river of starlight flowing through the night. In part 1, we stood before the heart of the cosmos, listening to the deep, steady heartbeat of fusion, the energy that nourishes all forms of life, all flames, all colors of the night sky. And when we listen long enough, we begin to realize the story does not end there. For light does not only reach us, it invites us to move. If the energy born from fusion can illuminate the sky for billions of years, then could it also carry humanity beyond the small boundary of Earth? Could we, creatures made of stardust, return to our origin, becoming travelers who carry that same light into the depths of the universe? This is no longer imagination. This is where fusion propulsion, the engine of light, enters the great dialogue between science and philosophy. Close your eyes for a moment and imagine a spacecraft drifting through the infinite darkness. No longer the harsh roar of chemical engines, no longer the violent shaking as though tearing open the sky. Instead, the ship lifts gently from Earth with a soft breath like push. A motion smooth, continuous, as quiet as the pulse of the sun. No hurry, no turbulence, just a steady, enduring, luminous flow of energy. Fusion propulsion with a power millions of times stronger than chemical engines allows the ship to accelerate continuously. This is the secret behind what used to be only dreams of science fiction. Reaching Mars in a matter of weeks, crossing the outer edge of the solar system in a few months, and perhaps touching the nearest stars within a single lifetime. If we keep accelerating even from a small initial speed, the ship will continue gathering momentum. And so, in the stillness of space, it inches toward fractions of the speed of light, what once seemed like the ultimate limit of human imagination. And in some quiet moment, looking out the spacecraft window, you may see the stars stretching into thin streams of light, as though time itself were dissolving in your hands. Arthur C. Clarke once wrote in Profiles of the Future, "The only way of discovering the limits of the possible is to venture a little way past them into the impossible." And truly, fusion propulsion is the door gently opening into that realm of the impossible. It doesn't only let us go farther, it allows us to think farther. And perhaps that is what makes us a species capable of dreaming. Yet what makes fusion propulsion sacred is not only its engineering. Engineering is merely the skeleton. What we feel now is its soul. For in every design of a fusion engine lies the imprint of human longing. Fusion rockets, bright white streams of plasma, like the radiant breath of a small sun pushing the ship forward. Direct fusion drive, where energy transforms directly into thrust, pure as primordial light. Magnetic confinement propulsion miniature tokamak chambers, where plasma whirls like a meditative circle, holding temperatures far beyond the sun's core. Inertial confinement engines, where each laser pulse compresses tiny fuel pellets into miniature suns, creating a heartbeat as steady as a cosmic pulse. These technologies, though complex and distant, are merely different ways of placing a little sun behind a spacecraft. A small sun powerful enough to take us into depths our ancestors never dared to imagine. But you know, dear listener, the most beautiful part is not the ship. It is the way the ship makes us look back at ourselves. When we ask how far can we go, we are really asking something much larger. How much within us remains undiscovered? When we watch the ship accelerate through infinite darkness, we see our own inner growth reflected there, a process slow, patient, enduring. Not loud, not demanding, but day by day bringing us closer to a deeper version of ourselves. Nietzsche once wrote in Thus Spoke Zarathustra, "And if you gaze long into an abyss, the abyss also gazes into you." Perhaps fusion propulsion is humanity's way of looking into that abyss, not with fear, but with hope. The hope that in the deepest darkness, there is always a light waiting to be found. Dear listener, if your eyelids feel heavier now, if your breath has grown softer and more, even if the image of a luminous ship drifting through space is gently lulling you, let that feeling arrive naturally. For this journey is not only about science, not only about the future of humanity, it is also about the future of your own mind, a mind softening, opening, growing lighter. Fusion propulsion reminds us that the universe is vast, but the human inner world is no less vast. And as you listen, let Carl Sagan's whisper from the cosmic connection echo softly. We make our world significant by the courage of our questions. And now, as we begin to understand the power of this engine of light, as we feel the warmth of a tiny sun glowing behind the ship, our journey gently leads to another question, a small one, yet deeply important. What fuel can nourish these little suns? Together we will discover the humble droplets of matter that contain enough energy to carry an entire civilization far beyond its own dreams. As the vessel of light drifts quietly through the vast dark regions of the cosmos, a small but significant moment arises, the moment when we ask ourselves what sustains that flame. A small sun, no matter how radiant, still needs fuel to continue burning. And if humanity dreams of traveling among the stars, we too must understand the humble droplets of matter that carry within themselves the compressed energy of the universe. Just as the inner light of a person only endures when nurtured by kindness, by small faiths, by quiet moments of peace, the flame of fusion also needs a source pure and gentle enough to keep its glow alive for as long as possible. Deuterium, tritium, helium-3 boron. Names that may sound dry or technical, yet through a philosophical lens, they resemble small stones lining a path, guiding humanity toward horizons far beyond what we once dared to imagine. And it is quietly beautiful to realize that the things that might one day carry us away from Earth are already hidden in seawater, in minerals, in lunar dust, and in tiny boron grains. There is something deeply human in that the greatest things often begin from the simplest origins. Deuterium, for example, is merely a special form of hydrogen with an extra neutron. It drifts gently through every ocean, resides in every drop of water, and exists within every living being. Yet inside that small particle lies enough energy to surpass any chemical fuel ever known. Imagine this: a single liter of seawater, if processed correctly, could power months of interstellar travel. In the endless expanse of space, this idea feels like a soft reminder we are never truly lacking. We simply have not yet learned to look deeply into what already exists. Tritium tells a different story, an isotope that can be grown. When lithium is struck by neutrons inside reactors, tritium emerges like a moment when the blessing of light transforms an ordinary element into fuel for journeys beyond the familiar. In a sense, tritium resembles the values we cultivate through hardship, not available from the start, forged only through experience, through impact, through the compression of time. But once it forms, it carries the strength to change everything. And then there is helium-3, a gas from the moon, and from the great oceans of gas giants regarded as the shining jewel of future clean energy. On the moon, helium-3 rests silently in beds of silver dust, unaware that one day humanity would look up and wonder, perhaps that place could provide the light for our first interstellar voyage. Helium-3 is truly clean, no neutron release, no long-lived radiation, a fuel as pure as a dream. Like the beautiful thoughts we keep quietly for ourselves until one day they become the very force that brings us beyond our limits. But deepest of all is the boron-proton fuel, which many scientists revere as holy. Neutron-free, non-toxic, generating no waste, a fuel so clean it borders on perfection. Yet to ignite boron, we require temperatures even hotter than the sun's core. And so it becomes a subtle symbol of philosophy. The purest things always demand the highest maturity. Not because they are difficult, but because they are truly worth it. Dear listener, If you are resting now under a dim light, your mind drifting along the thin boundary between wakefulness and sleep, try to feel this. All these fuels, deuterium, tritium, helium, boron, are symbols of endurance. They exist everywhere, steady, abundant, unending. Just like life. Just like the possibilities resting quietly within each of us. Just like the spiritual fuels we only need to touch for our inner light to rise again. Marcus Aurelius once wrote in Meditations, "Look well into yourself. There is a source of strength which will always spring up if you will always look." Perhaps he was not speaking of fusion yet. The line describes perfectly how these small fuels contain oceans of silent power. But the most beautiful part of this story is not merely that fusion fuels are abundant and accessible. The most beautiful truth is that for the first time in history, humanity may refuel itself while traveling beyond Earth. No need to return home. No need to depend on our birthplace. No longer bound by the limitations of where we came from. This is not just technology, this is the maturation of a civilization. And when a civilization learns to nourish its own energy, it begins at last to step out of childhood. Dear listener, if you are slowly sinking into the quiet of the night, let this thought gently accompany you, wherever we are on our journey, whether tired or uncertain. There are always fuels within us that never run dry, small things, yet enough to rekindle our own light. Deuterium is as small as a drop of water, boron as small as a grain of sand, yet both contain a kind of eternity. And so do you. Within the smallest parts of your being, there is always a universe waiting to be lit. And now, as we have come to understand the droplets of matter that nourish the engine of light as our journey has carried us from the heart of the stars to these humble fuels, it is time to step into a new chapter. Does humanity possess the strength to harness command and master such immense energy? A question that opens the path ahead, the immense technical challenges. As the previous chapter gently came to a close, we witnessed the quiet beauty of those pure fuels, small particles of matter carrying enough energy to take a civilization farther than our ancestors ever dared to imagine. And in the moment we recognize that abundance, a question rises soft as stardust. If the fuel is already here, what still keeps humanity from touching the miniature suns of its own creation? That question opens a doorway into a deeper realm of reflection where engineering meets philosophy and where the limits of physics mirror the inner limits we ourselves are learning to overcome. The truth is this: to create a fusion reaction to help two light nuclei overcome their electrostatic repulsion and unite humanity must build conditions that exist naturally only in the hearts of stars. The first condition, temperatures of hundreds of millions of degrees Celsius, hotter than the sun's core. So hot that matter ceases to be matter, dissolving into plasma, the state of absolute freedom, where electrons and nuclei no longer belong to each other. The second condition. The plasma must remain stable. Yet plasma behaves like a living being, trembling, swirling, oscillating, rebelling. Holding it steady is like trying to cradle a flame in your hands without letting it flare or fade. The third condition, containment by extraordinarily strong magnetic fields. No physical material can endure such heat, so scientists must use magnetism to embrace the plasma the same way we must use patience to hold our strongest emotions without letting them tear the mind apart. The fourth condition, materials that can withstand extreme radiation. For even if the plasma is held by magnetism, everything around it suffers, and the materials must be strong enough to accept both light and darkness. Dear listener, as you absorb these thoughts in the quiet of night, perhaps you sense that all these challenges, though they belong to physics, carry a very human meaning. To create light, we must face the most extreme states of our being. Nietzsche once wrote in Beyond Good and Evil, one must test oneself to see that one is destined for independence and command. His words apply not only to people, but also to fusion itself to create the purest energy the universe demands that we cross its harshest trials. There are two main paths to fusion. Magnetic confinement fusion held by magnetic fields. This is the world of tokamaks and stellarator structures swirling in circular forms like enormous meditative mandalas. Inside them, plasma rotates like a stream of light in deep meditation. Magnetic field lines wrap around it like invisible arms, keeping it from touching the chamber walls, keeping it alive. But to control plasma, we must understand the behavior of a beautiful kind of chaos. Plasma oscillates. Plasma ripples. Plasma grows angry when forced, and plasma disappears when not held with care. Much like the human mind, never still unless understood, never peaceful when constrained. 2. Inertial confinement fusion compressed by energy. This is the world of ultra-powerful laser pulses fired at a fuel pellet the size of a grain of sand, compressing it hundreds of times over in an instant. In that brief moment, the pellet becomes a tiny sun, brilliant, intense, and fleeting. Those flashes resemble moments of enlightenment in a human life, infinitesimally short. Yet when they happen, they transform everything. Projects like ITER-NIF and countless private ventures are racing toward what science calls ignition, a self-sustaining reaction where the plasma no longer needs external energy to keep burning. A flame that feeds itself. A sun that stands on its own within the reactor. If that moment comes, humanity will gain clean, infinite, sustainable energy. But to reach it, we must pass through countless difficulties: materials failing, magnetic fields, fluctuating laser beams, uneven colossal costs, and a patience that seems bottomless. Yet this very journey is what gives fusion its quiet beauty. For as Dostoevsky wrote in The Brothers Karamazov, it is suffering that gives rise to consciousness. The universe, it seems, uses this technical suffering to help humanity awaken. Dear listener, if your breath has slowed just a little as you hear this, that is a good sign. Let your mind drift with this rhythm, soft as plasma, flowing within a magnetic embrace. Fusion, after all, is not just a physical challenge, it is a spiritual trial for an entire civilization. It asks us, do you have the patience to nurture a sun? Do you have the stillness to understand chaos? Do you have the endurance to pursue the light? And once we step through those questions, another arises quietly behind them. What benefits await us on the other side of these challenges? As we stand before the immense challenges humanity must confront in order to create a miniature sun on Earth, we see trials that seem to lie far beyond human capability. Temperatures surpassing stellar cores, plasma, unruly and untamed materials, enduring extreme radiation and magnetic fields like invisible arms trying to hold a newborn celestial body in place. But if we have the patience to pass through those harsh gates, what awaits on the other side? The answer is a future so beautiful it makes the breath soften. Fusion is not merely a new source of energy, it is the promise of a mature civilization. And to understand why we must view fusion in relation to what we currently use, chemical energy and nuclear fission, allow me to tell you slowly, like the soft heartbeat of a sleeping planet. First of all, fusion creates no long-lived radioactive waste, no 1,000-year storage, no shadows lingering across generations, no landscape sealed away forever. Fusion is clean in a profoundly pure way, like dawnlight that leaves no trace on the mountain it touches. Dear listener, if you pay attention, you may notice the universe always favors what is harmonious. And fusion is one of the most harmonious processes nature has ever created. The second benefit, the dream of every scientist, is that fusion produces energy like millions of times stronger than chemical fuel. Remember that in chemical reactions, burning gasoline, hydrogen, methane, the energy comes only from electron movement. But in fusion, the energy comes directly from the nucleus, a uniting, a transformation, a light born from the very core of matter. Einstein foresaw this in Annalen der Physik through his famous equation E equals mc2. He could not have known that one day that equation would become the heart of interstellar vessels. Just a single gram of fusion fuel can produce as much energy as tons of chemical fuel. And if you look closely, there is a very human metaphor here too. Sometimes the greatest power comes from the smallest thing, from a particle, from a thought, from a moment. The third truth, fusion is safer than fission. No meltdown, no runaway chain reaction, no sleeping bomb. Fusion is a delicate flame. If we stop feeding it, it simply goes out. No explosion, no destruction, just a quiet disappearance. Feel that image for a moment, a flame that only shines when we are gentle enough to keep it alive. Like the peace within each of us, it exists only when tended with understanding and tenderness. But the most sacred benefit of fusion in space exploration is the fourth. Fusion allows continuous thrust, something chemical engines can never achieve. Continuous thrust is the dream of every ship yearning to break free from the limits of classical physics. No longer accelerating once and coasting endlessly. No longer drifting through months of darkness without momentum. Fusion allows a ship to accelerate continuously, decelerate continuously, sculpt its trajectory in curves, soft as an artist's brushstroke, and embark on journeys that once lived only in the pages of fiction. Imagine it a vessel like a drop of light continuously accelerating through the night, gentle, steady, so beautiful that even the surrounding silence feels compelled to listen to its motion. And then when we look at fusion through a philosophical lens, we realize it is not merely a technology, it is a metaphor. Fission separation carries the risk of fracture. Fusion union carries the promise of healing. We have lived long in a world of division, conflict, and competition. Now fusion, with its nature of uniting, becomes a symbol of the future humanity longs for. Carl Jung once wrote, "In modern man in search of a soul, the greatest and most important problems of life are all fundamentally insoluble. They can never be solved, only outgrown." Fusion is precisely that outgrowing. We do not fix the energy crisis by patching together old answers, but by stepping into an entirely new level. Dear listener, if your eyelids feel a little heavier now, if the words are dissolving into a gentle stream inside your mind, let yourself drift with it. For fusion is much like this state, still yet powerful, soft, yet profound, gentle, yet capable of transforming everything. And as you rest into this rhythm, remember that all the gifts of fusion, its cleanliness, its safety, its vast efficiency, its continuous thrust are not merely technological advances, but evolutions of human consciousness. We choose fusion not only because it is strong, but because it is beautiful. Not only because it is sustainable, but because it is harmonious. Not only because it is useful, but because it reflects something deeper, that humanity is learning to grow up. And as this thought settles softly within you, a small but important question emerges. A thin note guiding us into the next chapter. If fusion brings so many benefits, how will it be used in the exploration of the cosmos? We have stood still for a long, quiet moment before the future of humanity. A vision where fusion is no longer merely a physical reaction, but a symbol of a civilization that chooses unity over division, healing over destruction. And in that stillness, the next question arises softly like a breath brushing the surface of the mind. If fusion is so beautiful, where will it carry us? That question opens a doorway into a realm where the faraway dreams of our ancestors, the ones that once made them look up at the sky, suddenly feel closer than ever. Fusion does not merely change the energy of a spacecraft. It transforms the very nature of exploration. If chemical propulsion is like rowing a small boat across an endless ocean, then fusion is like raising a sail upon an eternal wind, a wind strong enough to carry us beyond boundaries once believed unbreakable. With fusion, humans are no longer chained by inertia or distance. We can accelerate continuously, pass by planets, move through the Kuiper Belt, reach the Oort cloud, the farthest rim of our solar home. What once lived only in imagination now becomes a soft breathing rhythm of science. Imagine another morning in humanity's future. A ship carrying a small group of brave travelers leaves Earth. Fusion does not propel them with explosive force, but with a gentle, continuous, persistent push. Mars, once a 6-month journey, becomes only a few weeks away. Europa, Jupiter's icy moon, whose hidden ocean may cradle life, is no longer just an image in a telescope, but a reachable world waiting beneath your fingertips. Titan, Saturn's dreamy golden moon, with its gift of a thick atmosphere and rivers and lakes made of liquid methane, begins to feel like a prehistoric echo of Earth itself. And beyond all that, fusion carries ships into the cold, dark regions where the Kuiper Belt and the Oort cloud drift like ancient fragments of memory. There we may find primordial relics, the first bricks of the solar system. Places once visible only through telescopes can become resting points along the route of exploration. Interstellar, for centuries, those two words were our most distant dream, the final horizon, a boundary humanity could look toward but never cross, until fusion arrived. Projects like Daedalus, Icarus, Orion, once believed to be sketches of the impossible, shifted from fantasy to doorway. Daedalus, designed to reach Barnard's star in 50 years. Icarus, its more ambitious descendant, aimed at the nearest star systems. Orion, the bold concept that used nuclear pulses for thrust. These designs were limited by technology and by time, but with fusion with continuous thrust and energy deep as an ocean 50 years becomes within a lifetime. Arthur C. Clarke wrote in The Promise of Space, "The limits of the possible can only be defined by going beyond them into the impossible." That is the spirit of interstellar travel, and fusion is the lamp lighting the way. One day, when humanity looks at Earth with the eyes of a wiser being, we will realize that this home cannot forever meet all our needs. A sustainable future requires us to look outward. Asteroids drifting stones of metal carry platinum, nickel, cobalt, even frozen water. These resources could sustain an entirely new era. Fusion allows extraction without burning fuel. A fusion-powered ship can travel to an asteroid stop harvest and continue its journey without ever returning to Earth for refueling. The universe then stops being a place to explore and becomes a network of resources, a new ocean for humanity. Fusion not only takes us far, it allows us to stay. Imagine an outpost on Mars, a research base beneath Europa's 10-kilometer ice shell, a city carved from basalt on the moon. All of these places require stable, powerful, clean energy. Solar power is too weak in distant places. Chemical fuels deplete. Fission is dangerous. Only fusion can keep an extraterrestrial settlement alive, expanding and growing. Nietzsche wrote in Thus Spoke Zarathustra, "You must be ready to burn yourself in your own flame. How could you rise anew if you have not first become ashes? A city on Mars will also need to be reborn from the ashes of old limitations. And fusion is the most beautiful flame to help it rise." Dear listener, if your mind is softening now as though drifting across a smooth black ocean, and the images of Mars Titan, the Oort cloud, are becoming faint lines of light in your imagination, let that feeling continue to spread. For fusion in its deepest meaning is not merely a scientific story. It is a story of potential, of expansion, of dreams growing alongside human wisdom. And when we imagine these distant applications, asteroid mining, off-world settlements, interstellar voyages, we are also seeing a larger version of ourselves. Now, a new question gently touches the mind. Where did this fusion journey begin? How did humanity move from simple observations to the colossal space projects of today as the spirit steps away from the fading images in the mind? The light ships gliding silently past Titan, sowing energy outposts upon the moon, anchoring themselves in the far Oort cloud like delicate heartbeats of humanity within all that vastness. A very human question rises quietly, soft as stardust settling into an open palm. How do we know all of this? A question gentle yet profound, guiding us back to the origin of all discovery history. Without history, there is no future. Without the silent footsteps and patient reflections of scientists and philosophers, humanity would never have reached the threshold of fusion as we have today. And so begins a journey backward through time, slow, tender, and full of light. In 1939, in a small room with a few sheets of paper and a patient mind, Hans Bethe accomplished something humanity had never done before. He explained how stars shine. He did not need to touch the sun. He did not need to fly into a star. He simply looked into equations like a meditator listening to the breath of the universe and perceived what was unfolding inside stellar cores. He identified the proton-proton chain and the CNO cycle, the processes through which hydrogen fuses into helium and releases energy. And from that moment on, humanity understood the light of the stars is not magic, it is fusion. The universe had long revealed its heart. Humanity had simply not been quiet enough to notice. If Bethe explained how stars breathe, then Einstein offered us the key to understanding why their energy is so immense. His famous equation in Annalen der Physik E = mc2 is not just mathematics, not just physics. It is one of the greatest poems the universe ever wrote. It tells us that mass heavy, still seemingly inert, can become energy light, free pure. And between them lies only the speed of light squared. As though the universe whispered, inside everything you believe to be heavy lies an ocean of light. Edward Teller and George Gamow were not only scientists, they were bold dreamers. They imagined the atomic nucleus the way a musician imagines invisible notes searching for ways those tiny particles could sing together in a nuclear harmony. Gamow, through a strange intuition, even described how protons could tunnel through the barrier of repulsion, a discovery carrying a deep philosophical echo that sometimes matter does not break through walls, it passes through them. Just like human limitations, we do not always overcome them through force, but through the transformation of perception. In the 1950s, the Soviet Union created the tokamak, a device that confines plasma with magnetic fields like invisible arms gently cradling a miniature sun. The tokamak was not merely technology, it was a symbol, a circle, a closed form, a perfect image of union. Inside it, plasma spins like a thought in meditation, hot, untamable, chaotic, yet held by the soft invisibility of magnetic fields. Looking at the tokamak, we learn a quiet lesson sometimes: what is strongest must be held by what is softest. Jeet, the joint. European Taurus became the next giant step, a place where nations set aside differences to unite in creating light. It was a fusion of humanity itself. There, for the very first time, we produced plasma, hotter than the sun's core stable, long enough for us to believe this path is real, not a dream. Jet was like the moment humanity first saw light reflected in its own eyes. Light not from the outside, but from its own unified effort. ITER is not a reactor. It is a declaration. A reminder that when humanity cooperates, we can recreate the energy of the stars. 34 nations. Thousands of scientists. One purpose: ignition, a self-sustaining reaction. ITER is a test of whether humanity can rise beyond itself, not only through science, but through union, the very essence of fusion. Nietzsche wrote in The Will to Power, "The secret of reaping the greatest fruitfulness and the greatest enjoyment from life is to live dangerously." ITER is that dangerous step, in the most beautiful sense, a daring to reach for light, not to destroy, but to recreate. Today, fusion no longer belongs only to governments. Private companies, bold, fast, visionary, are jumping into the race. Commonwealth Fusion Systems. Helion TAE Zap Energy. They carry the spirit of a new age, agile, daring, creative, willing to err, willing to try. If ITER is the test of cooperation, then these companies are the test of freedom. Together, they become two strands of thought in the human mind. One patient, the other hungry. One steady, the other explosive. This convergence brings fusion closer than it has ever been. Dear listener, if your breath has slowed by now, if your eyelids hang heavy like a small drifting cloud, and if these words are dissolving gently into the warm darkness around you, let yourself drift. For the history of fusion is not merely the history of science. It is the history of the times humanity looked into the darkness and chose to light a small flame. Carl Jung wrote in Memories, Dreams, Reflections, "One does not become enlightened by imagining figures of light, but by making the darkness conscious." Fusion follows that same path. We do not dream of light. We learn to understand the darkness, the chaotic plasma, the extreme physics, the immense challenges, so that one day light arises on its own. And as this historical journey closes softly, a new question opens thin as a thread leading us into the next chapter. If fusion is such a magnificent gift, does it come with ethical and legal risks? As our journey settles into silence, the echo of those quiet footsteps remains the footsteps that carried humanity from pages filled with symbols to colossal devices like tokamaks, jet, and ITER, where plasma circles like meditating halos beneath the Earth's surface. And then within that glow, a profoundly human question rises softly. If we can recreate the power of the stars, are we mature enough to use it? A gentle question, yet one whose weight surpasses every physical equation. It touches ethics, law, and the capacity for responsibility in a species learning how to enter cosmic adulthood. Fusion is a beautiful dream, but every great dream carries its own shadow. And to understand the light, we must look into the darkness, not to fear it, but to grow. Carl Jung once wrote in Psychology and Religion, "One does not become enlightened by imagining figures of light, but by making the darkness conscious." Fusion is the same. It is not only the light inside a reactor, but the darkness we must understand, the darkness of responsibility. Even though fusion is cleaner than fission, it is not entirely without risk. Tritium, a crucial fuel for many fusion reactions, is mildly radioactive. It glows not in a poetic sense, but in a technical one. To manage tritium, humanity must reach a higher level of discipline and subtlety than we have ever shown with nuclear energy. Containment, the act of holding light within magnetic arms, is not merely a technical challenge, but an ethical one. For if containment fails, if plasma touches the chamber wall, if magnetic systems collapse, everything can become dangerous. Fusion does not melt down like fission, yet we must still face risks of activated materials and strict environmental protection requirements. Humans often believe they control everything, but fusion reminds us power does not always come with awareness. Imagine a rocket carrying a fusion reactor leaving Earth. Even if fusion is safe in principle, the launch itself remains a delicate dance with risk. A rocket may explode, magnetic coils may fail, tritium may fall into the ocean or onto land. Each of these risks is a humble reminder the road to the stars demands not only intelligence, but also care and compassion for the planet that raised us. Nietzsche once wrote, in The Gay Science, he who climbs upon the highest mountains laughs at all tragedies, real or imaginary. But fusion does not let us laugh at tragedy. It demands seriousness, maturity, and responsibility. At present, there is no comprehensive international law governing fusion reactors in space. The 1967 Outer Space Treaty bans nuclear weapons in orbit, but says nothing about fusion as an energy system. This opens many questions. Who owns fusion technology in space? Who is responsible if an accident occurs? Could nations engage in a fusion-based arms race? Could there be an energy monopoly of the cosmos? These are not just legal questions. They are questions about the nature of humanity. Will we share or will we claim? Will we cooperate or compete? Will fusion become a common light or a tool of power? Arthur C. Clarke once wrote in Childhood's End, "The stars are not for man." But he spoke in a time when we did not yet know we were made of stardust. Today we understand that the stars are for us if we are mature enough. Exploring the cosmos is a dream, but protecting the cosmos is a responsibility. We cannot reach Titan Europa or other distant moons only to contaminate their primordial environments. We cannot mine asteroids recklessly without understanding the consequences, and we cannot build colonies on Mars while forgetting the purity of the red planet. Fusion, with its immense power, requires humanity to learn how to walk gently, like walking on fresh snow, like holding a small lantern in the night, like whispering without disturbing the universe. All of this leads us toward a profound philosophical question. How far into the universe do we have the right to go, and in what spirit Kant once wrote in Critique of Practical Reason? Two things fill the mind with ever-increasing wonder and awe: the starry heavens above me and the moral law within me. Fusion stands exactly between these two, the universe and ethics. Dear listener, if your breath has slowed, if your mind feels fluid, like water, if the philosophical questions are dissolving into mist, allow it. For the journey to the stars is not only outward, it is inward, into the consciousness of a species learning to grow. Fusion gives us the power of light, and with it, the responsibility of light. And as these reflections on ethics, law, and safety gently fade into the night, another door opens before us. If humanity overcomes these risks, how will fusion change the Earth itself? This question, soft as the last breath of night, leads us into, as these reflections slowly dissolve into the gentle darkness of night, the questions of ethics, responsibility, and safety that arise when humanity touches the power of the stars. We begin to realize something quiet, yet deeply true. Every technology, no matter how magnificent, eventually returns to shape the very planet that gave birth to it. Humanity's maturity in space does not depend only on our ability to travel among the stars, but on how we care for the first and deepest home we ever had, Earth. And so, like a natural flow, our journey approaches a new threshold, the threshold of expansion. Fusion, that small, delicate light we try to recreate inside Earth-bound reactors, is not only the engine that might take us far. It can also become the new heart of civilization here at home. From the cosmos back to Earth, and the miracle begins. Dear listener, close your eyes for a moment and imagine standing on a cliff overlooking the ocean. The night wind brushes past thin and gentle like the planet's steady breath. And you know that beneath the water, Earth continues to spin quietly like an ancient whisper. In that moment, you understand that all the exploration out there, no matter how far to Titan Europa or even Proxima Centauri, ultimately leads back here, back to the question, how do we nourish the planet that created us? Fusion offers a hopeful answer: clean energy for Earth, a new breath for civilization. One of the most beautiful things about fusion is this: it produces no smoke, no ash, no CO2, no marks of depletion. It produces only light. And helium, a gentle, harmless gas that rises into the sky like a soft smile. If we can master this process on Earth, our planet will enter a new chapter, one free from coal, oil, and gas. No more power plants exhaling heat into the sky. No more forests burned for land. No more oil slicks on the ocean. Fusion whispers to humanity: you can live without hurting the Earth. In Walden, Henry David Thoreau wrote, "Heaven is under our feet as well as over our heads. Heaven lies beneath us, and fusion may be part of the path to bring that heaven back." Reducing greenhouse gases, easing the sky's burden. Some afternoons, the sky dims as though breathing shallowly. Greenhouse gases heat the planet, raise the seas, and push the climate into anxious turbulence. Fusion burns nothing, creates no CO2, no toxins, no lingering wounds in the atmosphere. It simply turns mass into energy, clean, efficient, pure, just as the stars have done for billions of years. Fusion is not magic, but it is a promise that we can lift the weight off this planet's shoulders, that the sky can grow blue again as it once was. A post-fossil fuel civilization beyond dependence. Humanity has lived long in the age of fire. Fire for warmth, for cooking, for burning coal, oil, gas. We grew from fire, but fire also limited us. Fusion arrives as the turning of a page, a shift into a new chapter, a civilization no longer bound to fossil fuels, a civilization powered by light, literally. A civilization in which energy is no longer something to fight over, no longer a reason for war, no longer a resource that drains away. Friedrich Nietzsche once wrote, "In Thus spoke Zarathustra, you must have chaos within you to give birth to a dancing star." But perhaps after centuries of industrial chaos, we are finally ready for the moment when the star begins to dance softly, warmly, without harming anyone. Fusion is that dancing star, the lamp that could open a post-fossil fuel world beyond smoke, beyond scarcity. When space technology comes home to nourish Earth, many people think space technology and Earth technology are separate paths. But in truth, like rivers returning to the sea, every invention created for space eventually comes back to serve Earth. GPS, smartphone cameras, solar panels, all were born from space science. Fusion will be the same. Small tokamaks designed for starships may become reactors for remote communities. Stable plasma chambers built for interstellar travel may power entire cities. Advances in high-temperature superconductors may transform global electrical grids. Space is not only the dream of going far, it is the path that brings us home again. Expansion wider than physics. Expansion is not only about scaling power or infrastructure. Expansion is expanding consciousness. If fusion teaches us that stars can live inside a magnetic chamber, then it also teaches us that the future can live in our hands. This kind of expansion is the expansion of hope that one day no child will grow up on a polluted planet, that clean energy will be ordinary, not privileged, that humanity can live with Earth rather than living by taking too much from it. Dear listener, if your breath feels lighter now, if your thoughts move slowly, like small waves, and a gentle sense of hope is settling into you, let it spread. Because within the small light of fusion, we see the reflection of our species' greatest longing to live better, softer, kinder. And as this current softens like a still lake at night, a new question appears, quiet as a final breath of dusk. What still holds us back? What barriers still stand between humanity and that future? As our reflections fade gently into the soft darkness of night, the questions of ethics, responsibility, and safety that arise when humanity reaches for the power of the stars, we begin to sense a quietly human truth. Every dream, no matter how beautiful, must walk through the uneven paths of reality. The universe expands by its own natural law, but humans, to reach the universe, must learn to expand through effort and patience. Fusion may be the lamp of the future, but the road leading to that lamp is still paved with countless problems, yet unsolved. In Letters to a Young Poet. Rainer Maria Rilke advised, "Try to love the questions themselves." And perhaps fusion is one of those questions, a question we must love long before we understand it. The difficulty of achieving stable net energy gained the ancient riddle of fire. For decades, we have created the first sparks of fusion, but sustaining them, making output exceed input, remains as fragile as holding a candle in a storm. Plasma must be hotter than the sun's core. Magnetic fields must be stronger than any magnet humanity has ever built. Every tiny fluctuation can extinguish the reaction. Fusion is like a deep meditation if the mind wavers even once the light disappears. High-temperature superconductors, an unfinished bridge. To hold plasma within magnetic arms, we need superconducting magnets that are powerful yet consume little energy. But high-temperature superconductors remain a partially opened mystery. These materials are like doors left slightly ajar, promising a new world, but still requiring more knowledge, more patience, and more minds willing to try and to fail. Heat-resistant materials, the challenge of endurance. Fusion produces temperatures and radiation far beyond any existing technology. Reactor walls are struck continuously by high-energy neutrons. They erode, crack, reshape their internal structure. Like the human heart, if not resilient enough, it fractures under the pressure of its own inner light. We must create new material solids capable of standing between the fires of the stars. Plasma control, a delicate art within chaos. Plasma is not solid nor liquid, but a living environment always swirling, oscillating, rising like a sea of fire. To control it, we must understand motions as subtle as the rhythm of breath. A small oscillation can break equilibrium. A micro instability can end the reaction. Plasma teaches us a lesson: the strongest things are often the most fragile. Enormous research costs the burden of the real world. Though fusion is a beautiful light, it is fed by cold numbers, billions of dollars, decades of investment. Not all nations can step into this arena. Not all projects survive long enough to see success. Yet, like all of humanity's great undertakings, fusion demands steadfastness. It requires people who believe in what is coming, even if they may not live long enough to witness it. Public acceptance fears still unhealed. Even though fusion is safer than fission, the word nuclear still makes many shudder. Memories of Chernobyl and Fukushima remain scars in civilization. And though fusion cannot melt down, it must still pass through the psychological gates of millions. Changing perception is sometimes harder than changing technology. As Kierkegaard wrote, in fear and trembling anxiety is the dizziness of freedom. Humanity stands before the freedom of energy, and our dizziness is natural. International law has not caught up a road with no map. When fusion enters space, when fusion engines carry humans beyond orbit, when fusion stations rest on the moon or on asteroids, who will regulate them? Who has the right to deploy them? Who is responsible if an accident occurs? The world has no answers yet. Humanity is stepping into a new land, like the first explorers crossing the ocean with only pencil-drawn maps in their hands. Dear listener, if your mind feels light now like a small cloud drifting in the dark sky, let yourself rest. For these barriers, technological, material, financial, legal, psychological, are not walls meant to stop us. They are steps. Fusion is not a race of speed. It is a journey of collective maturity, a journey requiring patience, wisdom, and humility. And within that humility, a final question rises softly: if one day humanity overcomes all these barriers, what will the future look like? That question, a long sigh from the universe, leads us into the final chapter. As we leave behind the remaining barriers, those hazy mountains lingering on the horizon, we recognize something profoundly familiar in humanity's long journey. Every great dream must pass through darkness before it reaches the light. Just as night always precedes dawn, fusion too stands in that moment of transition, a moment when darkness is no longer an obstacle, but an invitation to continue. And at this threshold, the door to the future vision begins to open soft as the final breath of a long night. The greatest leap since the age of chemical rockets. From the day humanity built its first chemical rocket to break the pull of gravity, we opened a new chapter in our history. Chemical rockets were the first key lifting us from Earth to orbit, from orbit to the moon. But fusion propulsion is no longer merely a key. It is a doorway into an era where energy comes not from burning fuel, but from the very reaction that feeds the light of the universe. If chemical rockets were our first legs, fusion propulsion will be our wings. Carl Sagan once said in Cosmos, "Somewhere something incredible is waiting to be known." Fusion brings that incredible closer, transforming it from imagination into a reachable future. The key to an interplanetary migration era. Imagine a moment when humanity no longer resides on a single world. Not as a distant fantasy, but as reality caravans of people moving between planets, like the ancient migrations of our ancestors. But instead of crossing deserts or oceans, they cross the silent space between celestial bodies. Fusion, with its continuous acceleration, its abundant clean energy, its fuel available across the solar system, makes this possible. Migration to Mars is no longer a mission for a few nations, but a step forward for all humankind. On Titan, cities beneath the golden haze. On Europa, research sanctuaries under 10 kilometers of ice. On metal-rich asteroids, sustainable mining outposts. This is not just geographical expansion. It is the expansion of our understanding that we belong to the universe. Fusion, the force that carries us to the nearest stars. Under the night sky, when you look at a small twinkling star, remember that the distance between you and it is not only measured in light years, it is the distance between today's limits and tomorrow's potential. Fusion, propulsion can shorten that distance, not by magic, but by physics, steady, patient, elegant, like the logic woven through the cosmos. Fusion ships may reach several percent of the speed of light. These numbers seem small, but in cosmology they are monumental. Proxima Centauri, the closest star after the Sun, could be reached within decades, within a single lifetime. No more thousand-year missions, no more sent and never returned. We may become travelers of light, reaching worlds our ancestors knew only as points in the sky. Nietzsche once wrote in The Will to Power, "And if you gaze long into an abyss, the abyss also gazes into you." But when humanity gazes into the universe, perhaps the universe gazes back, not with coldness, but with welcome. The technology that lets us transcend time and distance time is the one thing we can never reclaim. Distance is the one thing we can never compress. And yet fusion, in its quiet, powerful way, allows us to touch both. When a fusion vessel accelerates continuously, it does more than shorten a journey, it transforms the human experience. Less time in harmful radiation. Fewer years spent in isolation, more opportunities to return home, more generations witnessing shared progress. Fusion reduces distance from barrier to equation, and philosophically it achieves something deeper. It opens the feeling that humanity can surpass itself not loudly but softly, like standing before the ocean and sensing your smallness, yet also your belonging to something infinitely vast. Thoreau once wrote in Walden, "Go confidently in the direction of your dreams." Fusion not only enlarges our dreams, it makes the path toward them real. The vision and the stillness of the mind. Dear listener, if your mind feels soft now like water under moonlight, let that stillness spread. For the future vision of fusion propulsion is not only a technological story, but a story of consciousness. Fusion reminds us that limits are not walls, but doors. Each generation opens them a little more. Each discovery moves us a little farther. Each dream lights a small flame. And perhaps one day, somewhere in a not-so-distant sky, humanity will look back on the dawn of this civilization and say, "This was when we began becoming creatures of many worlds." So as you relax your breath, feeling your heartbeat slow like a stable orbit, let the final reflections drift through you gently. Fusion is not only the light of the stars, it is the light within us. The light of hope, of longing, of soft and compassionate expansion. And as that light reaches the universe's deepest frontiers, we too expand inward, opening, unfolding soft as a night blooming flower.